Right, here we go again, in daylight. Okay, so I'm just looking at the important information here. It's about population change, going up, of course. So in 1940, right here, okay, in 1940, it was 132 million, okay? In 1950, it was 151 million. So I've written these as ordered pairs. Now, if I'm saying that 1940 is my starting year, okay, then that's t equals 0, okay? So 1950 is 10 years later, so that's t equals 10. So here's the ordered pairs for 1940, 132 million, and 1950, 151 million. Okay, I'm going to plot these two and draw a straight line through it. I've done that earlier. Okay, here we go. So there we go. Here's my 0 year here, 132 million. Okay, it's then 10 years later, this is 1950, it's 151 million, so again a bit over 150. Okay, I've plotted it and I've drawn a straight line, but I've also kind of extended it just in case. Who need, maybe there's some, what's it going to be in 20 years time, so I thought I'd project the line a little bit. Okay, so that's pretty much done there. Okay, now let's have a look at this. What's the average rate of change from 1940 to 1950? Now you can use a graph, you can use the points. So remember, let's go back to those points. It went, now if I do this, the average rate of change as a slope, I could use the y2 minus y1. So if I use y2, remember this one, minus y1, all over x2 minus x1, then I'll have this. Okay, so I'll call this my second set of xy's and this my first set. Okay, so that there is y2, okay, the second y, so 151. Take away the first y, which is the 132. Take the 132. Some of you might be able to see this already. Over, well, can you see that the change in the x, the change in the years is 10 years, okay, whether, if I'll write it in 10, take away 0, okay, again, x2, take away x1, and that's going to give me 19 over 10, okay, so I went up by 19 million in 10 years, so the average rate of change, let's put it over here, is going to be 1.9, isn't it, 19 divided by 10, so 1.9 million, okay, let's put that a million per year. That's the average rate of change, okay? It went up by 19 million in 10 years, so 19 divided by 10, 1.9 million per year. What is the slope of the line connecting the 2 points in part A? Well, that's it. All right, that's it. That's the slope, 1.9. Now, what's the practical meaning? Well, I've kind of already said it. The population is increasing by 1.9 million per year, okay? Right, what's the vertical intercept of this line? Well, let's go and have a look. There it is, okay, at 132. Okay. So, well, if I'm going to use right equation, I'm going to put plus 132. Remember the y-intercept? Stick that at the end. What's the slope? A 1.9. So, now normally I would write it like this, okay? I'd say it's like this. Y equals 1.9x plus 132, okay? If it's in terms of y and x. But let's have a look at the actual question. They want it in p and t, and okay, so function notation. There's the y, okay? There's the y in terms of t, which is the x, I suppose. So what we're going to say is this. The alternative is going to be this. Here we go. The population in terms of time, okay? P of t equals, just write 1.9t plus 132, okay? Just the same kind of thing. We could say that the first one is y equals mx plus b, the slope-intercept form. I've just written in function notation below, okay? So that's it. Now, remember, this question was all about a linear function, because, of course, population could do this and go up, and go up even steeper, but apparently between 1940 and 1950, that's like a nice straight line, so that's what they've done. And if I want to project any further information, okay, you know, in 20 years' time, now here's a little secret about this. I actually drew this, and I knew it was going to go through that point. Okay, I knew it was going to go through that point. The reason is, remember this. It went up, remember, it went up 19 in 10 years. Okay, so I went up another 19 in 10 years. Okay, and think about it, if that's 151, stick 19 on top, you'll get 170. An extra 10 years over to here. Okay, so that's why I went up 19 and went on 10 again. Now that was just to make my line more accurate, because I knew what was coming ahead. I could predict what was coming ahead if it's going up 19 every 10 years. Okay, but of course, who knows what's going to happen to population? Okay.